Okay.
If people aren't on the Slack, I've posted the Slack link in the chat as well, so you can go there and then go to Hash Jobs to post information. And I'll encourage people, especially for people that are looking for jobs, or if you might have one, just try to look at these people. And even if you don't have a job, if you see someone saying, "Hey, I'm looking for a job," see if maybe you can think about your network or anything, and just help people out that way would be great.
Excellent. Okay, well, we are very, very lucky to have another AWS hero here, Goran, to present to us on Java in Lambda. And I'd say, Grant, take it away and let people know if you want them to hold questions or just ask questions as they go. But
yeah, just ask questions as you go, because I want some feedback. I'm just tired of these conferences where you just present something and you don't see people, and I would really like to understand what's interesting for you and what's just boring, and just stop me if something is boring. Okay. So yeah, I'm working in Java for like billion years, and I've tried Java in many different environments, from standalone servers to specialized servers to now to managed servers like containers and Lambda. So there's a lot of experience, and I'm never happy, and I'm just trying to find something that would really work. Hopefully we have something really cool now, but whatever we do now in Lambda or Java, AWS, it's still not good enough. And you will see through this presentation that things are really rapidly changing. And even in during the last year, so many things happened in AWS with serverless that really improved it. And we can expect that in a year it's going to be even better. And one of these things, like connection between Lambdas and VPC, really helped in Java world, because most of these Java applications are actually really serious business applications that need relational databases, which are always in VPC. So things like that switched like from 30 seconds of call start to almost zero is just amazing, and that's what's really helped. So let me try to explain just first a few bits about.
Goran, are you screen sharing? I'm not seeing it.
I'm actually sharing my screen through the. I'm not screen sharing. I'm using my screen. You want me to start sharing?
If you change to speaker view, then you can see the presentation.
Speaker view.
Not you, everybody else. I mean,
okay.
Instead of seeing the grid of everybody.
Yeah, just switch to speaker view. Okay.
Okay, cool. Excellent. Thank you.
Okay. So, yeah, let's start. So, how does Lambda work with the CPU and memory? That's the most important thing for Java here. There is a scale between 128 megabytes to 3008 megabytes. That's a scale in megabytes that says how much memory will you get from Amazon for that particular run. But it also says how much of the CPU would you get. And there's a clear statement from Amazon that 1792 megabytes is equivalent to 1 virtual CPU per second. So you will get 1 virtual CPU token to use it in 1 second. Okay. So what does that mean? That doesn't if you use 128 megabytes, it doesn't mean that you will get some like 1/14th part of the CPU. You will always get one thread, and in that thread, your time will be split. Okay, so you will get like 1/14th of the time in 1 second. So whatever you do, you will always get one thread, but for the limited time. So some of your applications will finish in that time, and some will not. You always have to understand that these Lambdas work inside of Amazon Linux, and they use Linux kernel. Linux kernel is doing this switching of time between processes. So there's always an overhead that comes if you have a lower memory and lower CPU time. You will always need to switch, and you always lose some time. So it's better to have more and to spend and to not to switch these contexts. Okay, so it is great to have one CPU for more time. And if you look at this one, you look at this screen, you will see a screenshot from one of the applications from Alex Casalboni, who's also from AWS. This is the explanation on how things work with Lambdas. So you have in horizontal scale from 128 megabytes to 3008 megabytes. It shows how much time would your Lambda take to finish some operation. And you can see that with the smallest memory and CPU, it will take most of the time, the highest time. And then there is some sweet spot about 1 gigabyte where all these things come together. After that point of time, there is no point for you to increase this memory or CPU because your process will just work the same. Okay, so you always have to tune your own application and see how it will perform. So it's not easy to find this automatically. You have to check that. You know, there's no wait for at this moment for Amazon or you to do this totally automatically. Okay, you can use some you can use this project to attach it to one Lambda and see how it performs and look at it from during the time. What is the best configuration for your Lambda? Okay. So how Lambda performs and what is the life cycle of Lambda? So there are two parts. One part goes to Amazon and another part is on your side. So with every execution, you have something, some kind of a queue where all requests for Lambdas come. It doesn't really matter if it's API gateway or is a kind of a SQS or something. There's always some kind of a queue. So all these requests come to that queue, and then that someone who is operating that queue decides that, okay, I'm going to send this to this one, or this one container who's going to execute it. So AWS is the one who takes responsibility of downloading the code, starting a container, and then running the application. So on your side, you have this right part. You know, you have to start the application and then run it for all later executions. So let's see this code example of how things work. This is something that comes in this Bootstrap, the runtime part. Okay, so what's a Bootstrap? Bootstrap is just an application that when AWS starts a container, it looks for the Bootstrap application. It's just an application called Bootstrap, nothing special, and then it runs it. Okay, so what does that application look like if you make your own script and make it? So here's the breakdown. First, in the initial phase, you can find the line saying source lambda task root echo handler blah blah blah. So it's actually taking this script and running it. Okay, so what's that? That's an initialization phase. It just takes script, initializes all the environments, variables and stuff like that, and does nothing. Then there's a loop. That loop goes to this API. You can see that, and there's a HTTP call to an API saying, "Give me do you have something for me now so I can execute it?" So this opens a connection to an API, and the connection stays open till there is something for you. And then when there is something for you, you get the request, then you execute it, and once you get the response from your code, you need to call the API to send the response. So you see, there's a lot of things going on in all these requests. So this is something that you would do if you write your own handler, your own bootstrap, your own custom runtime. That's how it's called in AWS. So AWS has its own runtimes that they manage, and they have support for Java, Node.js, Python, and stuff like that. But then there comes an option for you to run your own runtime. When would you run? Why would you run your own runtime, and when would you do that? So if you need something really special, like Perl, PHP, you can run your own Linux stuff. You can write whatever you like, have support from some old languages, and and also if you want to run the fastest possible code, you can write something in C or C++, and then you will get the best performance probably. So you can choose, but then there are some consequences in this choice. When AWS does this management and has its own runtimes, they decide to give you some benefits for it. Okay, so let's see what are the benefits that you cannot easily find in specifications or documentation. Okay, so the whole bootstrap process can take maximum 10 seconds. If it's over 10 seconds, then it will fail and try it again. Okay, it can try like two times, if I can remember properly, and then it will fail. Okay, but then there's something cool that comes with AWS runtimes. You have free initialization phase. You don't pay for it, and during this phase, you get 1 virtual CPU per second. So that means that you can run something for 10 seconds for free during the initialization phase. That means that you can start your Java or any other, let's say, slow virtual machine, and you don't have to pay for that. So that's good if you have something running in batches where you don't really, in background, where you don't really need to have a real-time response, and because you won't pay for it. Okay, but if you have a website that needs to react automatically, dynamically to request, then maybe you're not in that great position with this. Okay, if you build your own runtime, you will not get this initialization phase for free. Okay, so bear that in mind, because some of these things that we will talk about in this presentation is related to custom runtimes. Okay. So there's also one important thing. Amazon introduced something called provision capacity for Lambdas last year. What does it mean? So that means that you can have one Lambda running and being ready for some call always. So you have to pay for that, but it will be there. There will be zero call start, zero initialization phase for someone, because whenever someone calls Lambda, it will just get the response, because all this initialization comes before. It's hidden for you. Amazon already did it. But the catch here is that you will be charged for that. Okay, and it doesn't really matter how much time will it take, but you will be charged for it. So what's good about these things also is that if you set your Lambda to 128 megabytes, you will pay the least price, but you will still get 1 virtual CPU during initialization. So most of the Lambdas that we will talk about today will have a really short time when they execute, when the handle executes, but they take a lot of time to initialize. So that's a good thing that Amazon did for us. So we get extra capacity to have some burst capacity to run something during initialization, and then we can later just execute normally as we do it. So you can also use this phase to do some extra stuff like connecting to databases. Even some people actually did some real business stuff because it's free, in this phase. So it's interesting. You can experiment with this, but it's there. So let's see some code. Okay. So I have one project for you. What we're going to do now is we're going to try to build one custom runtime and run our code in that custom runtime. That's what we're going to do during this presentation. But let's see what does it mean. That means that we need to compile Java to some native code. What does it mean native? Native means it should run in Linux, because as I said, Lambdas run in Amazon Linux. Okay. So we have some code. Let's edit it so we can prove that it's actually done. Okay. So I have some help from myself here. Okay, so I will now compile it. I'll now build a jar. Sorry. And now I can run it. Okay, so this is running in Java Virtual Machine. Okay, it took some time for Java Virtual Machine to start and then to show this. But my Java Virtual Machine was already running, so it's probably hidden that cost of starting this. So let's do something new now. Let's compile this Java class to a native code in Linux. Okay, so this is how we do it. This is actually using technology from Oracle called GraalVM. GraalVM consists of a small virtual machine and a small garbage collector, and it tries to compile this small piece of Java code into native. So what we have now in this folder is an application called demo. I can run it. It will say hi Boston, but it's not Java anymore. It's actually a dynamically compiled, dynamically linked binary in Linux. Okay, so these are the binaries. These are the libraries that it is dynamically linked to. Okay.
Goran, could you do a file on demo?
Yeah, that's true. Yeah. So this is it.
Oh wow, that's cool.
So that's Linux. Okay. So there's no more Java. I can run this in almost any Linux. Okay. So what is the difference? Well, maybe if I copy this thing into environment where the Lambdas run, well, maybe Amazon Linux version that runs in this container will not have these exact versions of these dynamic of these libraries. So let's do another step. Let's compile this into a completely static file. Okay. So you'll see that this takes more time than compiling in Java, just Java to Java bytecode. Okay. But at the end, we'll have something which is, okay. So you see this now, statically linked, not a dynamic executable. So you see, so we have a statically compiled file that we can now run on any Linux machine. Okay. So what is it good for also? Check this one. Let me resize this. So what you can do with this, you can actually build. Can you see this, guys?
Yes.
You can build a Docker file that has nothing on these layers below. Just a demo application, and that's it. That's the minimal Docker that you can have. So what if we put like a web server in this? What if we put something that can respond to something, you know? So that's the goal. Let's go into that direction, and you will see that we will have some code that we can pack in Lambdas, but also we can pack in Dockers, and it will run in a totally different way. So what does it mean, totally different way? It will take much less memory. There is no virtual machine. So instead of like taking hundreds of megabytes of RAM, it will just take maybe 20, 30 megabytes of RAM. Okay. It will also take much less time to start. Okay. So this is good. You know, there's nothing to complain about this thing, but why don't we just do it like in everything we do? Well, there are some limitations here. So let's go back and see what are the issues. So Graal VM technology runs a simple virtual machine and a simple garbage collector. But it requires that you prepare everything ahead of time, so you can compile it ahead of time, okay? So there is no way to introduce some stuff which are typical to Java. So you cannot dynamically load something later, because native code without Java virtual machine cannot load some Java, okay? So no vars, no dynamic stuff like loading other programs and stuff like that. So what do we also need to do? You know, we need to statically connect everything in this application so we can make final static file of it. So why is that a problem in Java? Because in Java we tend to use many dynamic stuff like dependency injections, where we can later connect something, you know. But in Lambdas, in most cases, in almost all cases practically, we always know what this application will do. So like let's say we use a Hibernate or some ORM or of some kind. In ORMs, you have support to switch your database from MySQL to Postgre to Oracle or something. So when do you do that? Almost never. I mean, I've never heard anyone did that, you know, so that's a problem, you know. But we still have these dynamic capabilities there. And you can switch it easy. You can even switch some of these things in run when the application is running. So you know that's cool, but you don't do that in real life. You know, so many of these dynamic things are there, and they're there just because it was easy for us to add them. You know, and you know we were running servers which start like for minutes, and it doesn't really matter because once they start, they're running very fast. Because Java is great, and when it's hot, it's great, but it just takes time for it to get hot. You know, for the garbage collector and virtual machine to understand what is it running, and then it's super fast. But now we have Lambdas. We have to start as soon as possible, and we don't have all this time to load stuff, dynamically load stuff. So yeah, we need to do something with our code in Java to prepare it so we can compile it natively. What does that mean? So all these dynamic stuff needs to be connected statically before we start compiling things. You know, so all configuration things need to be loaded and put into static files or static classes, so we don't need to any dynamic option in it. So we need to prepare everything and then we can compile. So that's a big issue. That's something we need to see how these things work. So let's jump to another demo. So here we have a application that runs. Okay, just let me close some of these things. Okay, so here's the Lambda. Let me try to resize the screen. Okay, so here's the Lambda in Java. So what does the Lambda do? it has some handler that will process every single request. It's a simple thing. It's a processing service is just receiving input object and then sending it back. That's it. And if you look at this, you can see that this service is injected dynamically in this class. Okay, so if you do that in a normal in standard Java and try to compile that to GraalVM, it won't be possible, you know, because these dynamic things that happen when we start the application, they are not allowed. There is no Java after we start the application, after we compile it. It's just a Linux code. So what is this that we're using now? So this is this example is run in a framework called Quarkus, done by Red Hat. So this framework is doing a job for us. So it's automatically, statically connecting these things. So when we compile it, the system will actually make some new classes that will be statically linked. Okay, statically linked in Java, I mean. Okay, so when the code in Java is actually ready for native compilation, the system will start the GraalVM compiler. It will work fine. Okay, so what does that mean? That means that we can actually use some old Java code that does dependency injection and still have these capabilities of static things, because these dynamic things are not that dynamic, because in real world, these things always work the same way, you know. There's nothing dynamic here. It's just the connection that we're making here. So let's see what's going to happen if we and how we're going to run this Lambda. So yeah, so this is my code here. So let's compile it. So this is compiling. It's actually doing reconfiguration of the code, and here is the payload that is in this payload file, and let's change it. Payload JSON, serverless Boston, hi Boston. Let's change the code, and let's do something with this. Let's check if I have a function there. So I've compiled it to Java now. It's not yet native, okay? It's still virtual machine, but it's just statically compiled, okay? So I'm gonna call this function, and this function did AWS client call to a server that actually created a function on the server from this code. Okay, so it's gonna be Java 11 runtime. Its memory size is 256, okay? So it's this class runtime handler, okay? So the function is created on server, it's fine. So now let's invoke it. So I'm sending my payload, and I got result from the server. So let's see what we got from the server. So the whole process of initialization, it took like 1.7 seconds, okay? But look at this one. We were actually built only 300 milliseconds, not 1.7 seconds, okay? Because we got this for free from AWS. So why we were charged 300? We were charged because the handler phase took 280 milliseconds, okay? So also one more thing is, we had 256 megabytes. We chose that option, but we used only 120 megabytes. So what I did, this is not just regular Java. It was Java compiled with Quarkus. So it's all static. It's already better than typical Java thing, okay? So now let's go to another step. Okay, so another step is let's build it from here. Let's build it to a static version. So I can do this here by using this Maven command, Maven package native. But don't forget, I'm running this in Linux. Okay, so in Linux I can already build stuff in Linux. But if you're doing this in Mac or some other Windows,
Hey,
you would
Goran,
use sorry.
I think you've gone dark on us. Just in the last
sorry.
10 seconds.
Sure, it's gone dark.
Just give me a second. Let me check why it's happened. Sorry.
Better? Worse?
Back for a second.
Is it plugged in?
Just a second. Just a second.
If I shake my phone, the flashlight comes on. Doesn't help. I still can't see him.
Well, I just lost. Strange. Just give me a second, okay?
Yep.
Just I'm here. You can hear me. Just a second. The OBS is just.
We can see it now.
Yeah. Okay.
Never,
Just a second. I'll restart the OBS.
I was curious about how well OBS worked.
It's usually great, but I don't know.
Now you know.
Hey, Brian, while we're waiting for technical difficulties,
Yeah.
we have raffles today, yes?
So I'm back, guys. I think it's fine now. Yeah. Can you see this now? It's fine?
Yep.
Okay, so I was here like 10 seconds ago. So because I'm running this on Linux, I can automatically compile this to native Linux code. But if you're running this in Mac or Windows, you would use this command that would use the Docker to build it inside the Docker. Okay, so I'll do it natively now on this Linux machine. Okay, so it will automatically first it will compile to Quarkus version, and then it will compile this code to a statically linked native application. So let's see. So it takes much more time to compile it to native. So this is not good for development. You would not use this on daily basis for development. You know, you would do this in CI/CD process where it doesn't really make any difference to make. Well, it does, you know, but where it's easier to compile. Also, you can if you have two different CI/CDs, one for development and one for production, you can use the one from developers to and run everything just in Java, and then in production you will compile it to native. You know. So now we have something, and now let's deploy this one like this. I'll try and do something. Let me delete. Sorry. Let me have a clear function. So I'm going to create a native one. So it's created now. So let's invoke it and see what happens. Okay. So what is the difference? The entire initialization phase took only 200 milliseconds, which is totally on pair with Node.js and stuff like that. Okay. Another thing is that total memory it's used is only 55 megabytes. But don't forget that this is just the simplest possible lambda, and with a more complicated lambdas, it would the save that we had like maybe 2 or 3 times less is even higher. Okay, and the duration also it took less time. So it's good, you know, but it takes more time to compile. It takes less time to initialize, but don't forget here, now we are charged for everything, you know, so it's not free anymore, okay? Because Amazon doesn't know what are we doing here. Because with Java or with their own runtimes, they have a control what's going on. Here, you do what you are on your own. They don't know it's Java. So why is this also good? Well, if you have Java 15, you want to run Lambdas in Java 15, you can compile them. You can make Java and compile it to Java 15 and compile it to native, and you'll have a running executable file. So it doesn't really matter. So yeah, these are the differences, you know. And why don't we do that all the time? Because we don't do that because it's hard, you know. We don't have a solution to convert everything into this, because in many cases code is not written in a way that it's easily statically linked, okay? And you know, dependencies that we have in our code are so bad that it's so hard for these compilers to understand them. So what do we need to do that to fix this? So Red Hat took this direction, and they said, well, we will pick the most important frameworks that we have in the market, and we'll build extensions that will map what we need to make these dynamic things to something which is looks like native. So let me give you a few examples. So if you have a Hibernate library in your system, the first time you start the Hibernate, it will look for all the configuration of mapping between the classes and databases, and it may be in XML or something like that. So it will run an XML file, and it will start the XML parser. It will do the whole parsing part, and then you will be able to use your application. With Quarkus, during the compile time, this extension will now know how to map the XML configuration to static Java classes. So you will do the whole thing of remapping the configuration into static files. What does that mean in production? Well, that means that if the compiler is smart enough and understands that we already used the XML for parsing, that means that we don't need an XML for production. So it will just remove it from the application. Okay, so smart compiler can actually understand what is necessary in production and remove all that code. Okay, so don't forget, Quarkus is making Java code from what we have, from what we started. And that Java code that we get, this is something new, something in between. Okay, it will help us run later things. It will help us compile things later in GraalVM. Okay, so one more thing about dependencies, for example, is that about what do we put in these dependencies. JDBC driver, that's a great example. I've heard JDBC driver has a dependency with JavaFX. It's a library for user interfaces in making complex user interfaces for desktop Java. Why does it have it? Well, because if you're making connection from a desktop to a database, and the password is wrong, someone needs to show you the application that says, well, the password is wrong, you should type again your password. You know, you don't have that in Lambdas. It's a server. You don't need these things. So they put as time goes by, just all these libraries add extra dependencies because someone is bored and, you know, let's do something new because our application is so old. And then we get a bundle of so many things that we don't really need. So what's good is that these compilers can actually look at the what's from the entry point of the application to through all the paths that the code can go, and these application, this compiler can actually say, well, I don't need most of these things now. So that's a cool thing. Okay. So yeah, let's go back and let's go back to the presentation. And so what do we need to get rid of? We need to get rid of reflection, which is like reading Java dynamically, reading Java classes dynamically. We need to get rid of dependency injection in a way that, well, you know, why do we have it? Well, can we get rid of it totally? You know, well, maybe we should not get rid of it totally because we have so much code that's done doing that in that way. But in reality, let's stick to what we really need. And so compilers can actually understand it easily because most of these things are not dynamic, as I said. So we have to get rid of class loaders and stuff and we have to fix the configuration stuff, because if you have like 5-10 dependencies in your project and every single dependency has its own configuration style, you cannot really handle all these things, you know. So Quarkus extensions help us map any configuration that any dependency has into its own simple static compiled configuration. Okay, so solution is to have smart compilers that will do the analysis. What's closed word assumption? That means that, okay, this is what we have, there's nothing else. If we don't include it now, it will not appear in the production. So let's avoid lazy loading. Some frameworks report not fair times for the startup, like in terms of how much time they need for a cold start, because they do some things later in the execution phase. There's no later here in Lambdas. We have to do it as soon as possible, you know. So as I said, if you must do it, you put it in initialization phase, because you will get extra CPU time, you know. And okay, so we have to do some changes, you know, but it's not easy. So in order to do these changes, some guys did some great job even before Oracle came with this GraalVM. So I would say that I said some good things about Quarkus, but there's also another project called Micronaut, and for me it's I like Quarkus for some reasons I will tell you later, but I would say that everyone should who loves Java should experiment with both. You know, they have a kind of different style. You know, Micronaut tends to remove everything that dynamic, you know, and still to make the working in the application cool, you know. And they tend to make its own project, you know. And Quarkus has a different style, tries to integrate all the existing frameworks. So, but these differences are not that big, you know. And and these guys are so enthusiastic and they push a lot. So I really like you to check all these things. Micronaut or Quarkus doesn't really matter. It's just a new direction in Java. And I like this guy, Graham Roche. He's just so passionate about these things. So just listen to him and you understand where we are going now. So this is big change in Java world that happens in the last year or two. And they even started doing these things before Oracle started with the GraalVM. We get improvements with statical linking even without native compilation. So of course, the Quarkus that I was telling you, it comes from Red Hat. Good thing is that if you are a Java EE developer or Jakarta EE now, you will find some of these things so cool, and you will easily move your application to Quarkus. And it also implements the micro profile, which is kind of a new standard for those guys coming from Jakarta EE. It's simple and it brings you so many libraries that really fix most of the cloud stuff and problems that we have. And of course, they solve problems with extensions. They tend to allow you to use any library around and then connect it to Quarkus. So you don't need to change your libraries. You can just use Hibernate. You can just use Redis. You can. They just make the extension to map it. With Micronaut, it's a bit different style. So this is how Quarkus marketing explains the differences. So with Quarkus that has a compilation to native with a simple REST, they say that the result is like 12 megabytes of memory, And with Quarkus just running in JVM, it's 73, and traditional Java or it's a bit more. So these things vary. You have to have real examples, but these differences look really like that, like relations between these options. And the startup times, look at this. They say 16 milliseconds to start Quarkus native, and almost a second to run a Quarkus with Java, which is close to what we have. Don't forget that we just that our container had only 256 megabytes of memory, so it's not a full CPU. And these numbers are with the CPU, one CPU. Okay. So let's see what Quarkus brings to Java developers who already have some applications and need to switch to Quarkus. Well, typical style for an application built in Jakarta EE would be to have REST interfaces dynamically connected through annotations like this. So by making, if you're not coming from Java world, well, look at this. So this is just a function that does this, return hello name. Okay, but by adding these annotations, I would say that, well, when I run this application, please start the web server and make this mapping to it. So when someone calls hello / some name, please push that name to a parameter of a function, and then so I can use it. So what will happen in Java? It will just start everything from the scratch and start the server, make the mapping, everything for you. So you just make this one class and that's it. So this all happens dynamically, and that's a problem for us, as we said. So we need to still use this code, but to make it work in a native way. So if I'm a Java developer, I would start something like this. If you can see the command here, it's a development mode in Quarkus. What does that mean? That if I start it, it will run a compilation and start a web server. So I'll open this link. Oh, sorry. Switching from Mac to Linux all the time. Okay. So /8080. Okay, there's nothing here, but now we type hello /Boston. It will return hello Boston. Okay, but look at this now for Java developers. This is going to be cool. So I can just change something in code and save it, and look at this. It will automatically work. So Quarkus is automatically recompiling everything for us, and it's not restarting the virtual machine. So you don't really need to recompile the application after you do some changes. For developers, this is such a great change. Previously you would be required to use some external applications that had some options to do something like this, but it was hard in Java. With Quarkus, it's amazing. Now you can really work like you're doing in some scripting language. Okay. So this is what you do here locally. You have a web server running. It's actually netty, started in this machine. It's listening to some port 8080 and / adding a REST endpoint with hello and /name. Okay. So, but in Amazon, we don't have a netty. We have an API gateway, and then we have our Lambda. So what we can do about it, how can we use absolutely the same application and run the same thing in Amazon? Well, look, let's try this. Let's build this. Let me show you. So I'm gonna build it now. Okay, I made some changes. Sorry, in code. Just give me a second. So it didn't pass tests. Sorry. Okay. Okay, so it's compiled now. So I will now call a SAM client for Amazon to deploy, to build the CloudFormation template and deploy this code. I can show you the SAM template. The Quarkus already does that for you. So it's SAM JVM YAML. So this is it. This is how it looks like. Okay. So there's going to be an API that's going to call this Lambda. So the memory size will be 512 megabytes. Okay. So let's do that. Let's package this. Let's make this code and let's do this. So it's building a CloudFormation template, and now we're going to deploy this stack. So it's now deploying to Amazon. Creating resources. Creating API gateway stage permissions. Okay, now we have our API gateway endpoint, and let's do something with it. Sorry, I have to copy it. I have to paste it here. So let's paste it and let's add hello and let's add be serverless. So takes some time, but it's now running. So this is the exactly same application that we have on our PC. Okay, so absolutely the same application. So it took some time for it to run the first time, but now it's just running perfectly fine. It has a bit longer startup time. Okay, and also the thing that I just compiled is still not native one. This was just Java virtual machine one, but I can compile this natively, and I would get a Linux executable, which is actually a small web server which is running only this thing. So developers who already have some code in Java and especially those coming from a Java EE world or Spring Boot or similar frameworks would recognize these REST annotations, and they would be able to easily move this thing. But also a great thing is that they will be able to keep the same style of coding, like a small local web server, and still deploy it to the cloud. So that's a great thing, because so many applications there we need to migrate them to the cloud, and with the least possible effort. Okay, let's switch back. So yeah, we just made this Lambda running, and yeah, it just does hello world and returns what we just sent to it. But most of the Lambdas do something else after we connect to them. So it's usually, if you're in AWS, you would call some other services, do something with them. So if you're doing that in Java, make sure you switch to SDK version 2. It has a lot of improvements in terms of loading and startup time and dependencies and stuff like that. So also try to avoid SDK detecting the configuration that it needs to run. So if you need an endpoint, don't let it go dynamically through the configuration of the system and try to determine in which region you are or which endpoint it has to connect to. Also, as of September 8, there is a new web client that is much better than the one coming in Java or even default one that was used in SDK before. So it's completely new HTTP client written in Java. So you can see differences that they say here that will happen in startup time. So it's more than a second, in time for the call start. So make sure you do all these changes, and so there's some other good things coming in this HTTP client, but it's one of the most important things to switch the proper HTTP client in your application. Okay. Some new cool stuff that are coming to Java. Since Java 10, we have something called application class data sharing. It's something that is similar to what we just saw, but look at in a different way. Let's say we have an application with so many dynamic things, and let's start the application. Let's let the system acknowledge all these dynamically loaded things, and then let's take a snapshot of the system and all these classes that we just mapped, and let's save it somewhere so we can reuse it again. So imagine that you started your Lambda, you have all the Hibernate configuration and stuff. You save it to some file, and then when you call it again, when you have a new container running the Java, instead of waiting for the system to dynamically load all these things, you can just read it from the file and start magically where the previous container stopped. So you make this thing during the compilation time. You start your application, let it do something, run, and then save the configuration of the classes. Okay. So this is the general idea of it. It's not perfect. It's you cannot just run your application just like that, and not all these things can be really saved. But it promises something. It gets like a half time for cold start and a lot less memory to run. And also in April this year, some new project Laden was proposed. It's also it's similar to Graal VM, but there's an extension to current extension to current Java that will, if I understand it correctly, it should make something similar to what Quarkus does, that these static mapping of the system will be now compiled. So it's called static Java image of the application. Okay, so it will be inside the OpenJDK. So, and there's a statement in this email correspondence from AWS that they're very happy with this, and I would say that Amazon is going to invest pretty hard in this. It's notable because Amazon is just released a version of Corretto, which is also which is an OpenJDK from AWS, and they're obviously pushing that a lot because these improvements coming in new Java versions will actually make the real difference in Lambdas. For those of you who love Java and love Lambdas, I really recommend this book from Mike Roberts and John Chapin. It's a great book. It doesn't have anything that I was talking about today, this new stuff, but it really says a lot about how you can optimize the system before you even come to this point to optimize it compiling into native. You know, and also the book is full of stuff. It's criticizing Amazon in many ways, especially like provision concurrency and stuff like that, which I really hate. So this is really a good source for so many things, so many great things in Java and in AWS. Okay, so these are some of the sources that I would really recommend for you to check. Stefano Bugliani presentation from, he's also in AWS. He's a really smart guy, and he did a presentation on reInvent about this, how to cut the time for cold start for standard Java. It's a full of great tips. Okay. Link from Michael Hart is about how he used this free init time in Java Lambdas to do some actual business code. Okay, it was just for fun, but it's cool. You know, it proved that you can really have this for free. And some links for Micronaut and Passionate Grant Rocher that I mentioned, and also Shane Grinovero. Okay, he's a guy from Red Hat and very, very good in explaining things about Quarkus. I'll share these links later. Okay, so this one is broken. So okay, I don't know why, but this is for about Q&A. So guys, do you have any questions?
And before we go to questions, I'll just tell people we do have a really cool raffle item. So stick around for that, but please ask questions.
I do have a question. I'm curious. I love Java, and it's always my first language of choice. But I'm wondering if you have an opinion, if you're able to, at work, you know, choose a language. Is it wise to use something else in order to not have to do all these gymnastics you were just teaching us? Or, you know, I guess my familiarity with Java makes me want to use Java, but I'm just wondering if it's better to spend time learning a different language or learning these methods, I guess is my question.
So you've heard about CDK, about writing infrastructure as a code.
Yes.
And I just couldn't use it with Java. I just tried and I just failed. It's so somehow just so complicated. So I used the TypeScript version. And it's a similar feeling to Java, but in many terms like using JSONs, and it's just simple, you know. So I liked it, and I would suggest anyone to just switch languages as they like, you know. And in terms of all these gymnastics, it's there because we have some legacy, you know, and we need to, and it's a lot of, it's a giant investment, and we need to move all these things to the future, and we cannot stop it, you know, just like that. And in terms of why I'm using Java in my company with this for Lambdas only, it's the stability of the system, of the whole system of testing, and all these dependencies that we use is so it's so well tested. These products are so great, you know, and I'm so confident in code we make in Java. So I would push in Java direction. I had so many problems with Node.js and a reactive way of thinking, but maybe that's because we were not used to that. Okay, so I would say try everything and use any tools you like. You know, I would go for Java if you are familiar with Java, but just don't forget that sometimes if your Lambda is a user, facing to a user, if you need a super short call start time, I mean, maybe Java is not perfect for some things. You know, just pick whatever you like. And also in Amazon, AWS, sorry, is investing a lot in AWS integration stuff. You know, which means that you don't really need to code anything. You just make a conversion template between your REST request and, let's say, DynamoDB API. So you don't need to do any coding. You just need to map request to another request. So in many cases in Lambda, in AWS, it's a perfect solution. You don't have a cold start. You just connect two services. So just think about how many times you actually just connect services. You know, maybe your code is not necessary at all. So that's the answer.
Right. Thank you.
Okay. You like the speed of native stuff? It's so hard. I've checked someone was trying to make Node.js compile to native. It's almost impossible. It's so hard because they do so many things dynamically in real time.
Yeah,
So
I will
I
say.
think.
Go ahead, Ken.
Brian.
I was just going to say I was blown away by the speed and the memory reduction. I will say I programmed in Java for a long time, and I don't anymore. But the numbers you had for speed and memory footprint were just astonishing.
Yeah, I mean, you don't really have to use this for Lambda only. You know, you can use it in Dockers also, in Fargate or something. So you just pick the smallest possible virtual machine. It will be just fine for this. You know, so that's great. You can even run this in ARM CPUs. So it has the smallest possible footprint. There is one thing that I forgot to say. Java, when it's hot, it's faster than native. Okay, it's one thing which is important to understand, because Java memory handling it's brilliant. You know, it knows how to cache things and fetch things which were used or not used, and the way it connects different classes, it's marvelous. It's it's maybe 20 to 30% slower to run native than Java when it's hot. You know, so event handlers may have a difference like 1 millisecond to 1.3 milliseconds. You know, you would not see that difference. Okay, so for the startup time, native is faster, but for running later, Java is actually faster. You know, so think about that. It's not maybe a big deal because we're still paying 100 milliseconds, even we just run for 1 millisecond. You know, so what's the number one on wish list for for reInvent? Just start pricing per millisecond, not per 100 milliseconds. You know, so it's not fair. You know, you see the numbers. It's 1 millisecond per request. So what's the catch? You know, we pay 100 times more.
Geez, I remember when we paid EC2 by the hour.
Yeah, that's true. Yeah, that's true.
Hey, this is Alex. I have a question for you.
Yeah.
So it sounds to me that serverless is definitely the future in a lot of programs and a lot of projects out there. In your opinion, is like looking at 2 to 3 to 5 years in the future, is Java going to play more of a role, less of a role, and just serverless in general? It's just a general question.
So, like 15 years ago, my company started a software as a service solution, which was running in Tomcat. It was some kind of a monolith. Okay, so in the last 15 years, we switched many servers that were coming, and we switched to Spring. Then we switched to what was that? Payara. It's a Java EE solution, you know. And then we switched to Quarkus, and then we switched to Lambda. So all these years we were pushing the same kind of same technology, you know, but it was actually very different, you know, because we are pursuing something different. Now with Lambdas, we are pursuing like this speed, you know. This is we need to fix the cold start. We didn't think about the cold start like 5 years ago. We didn't care about that, you know. So who knows what will be important in like 5 years? That's a big question. Okay, so what I think that from my previous answers is that service integrations are maybe the future, maybe even less code, because if you look at most of the code that we do now in Java is just connecting services. We don't really need that code. Okay, so what's good is that when you do things in CDK, when you define the infrastructure, okay, I have this API gateway, I have this DynamoDB table. You can actually, in TypeScript, in CDK, define that connection between REST API and the DynamoDB. So when you receive a request from web form, it will automatically save it to Dynamo. So if you don't have any complex transformations, that will be enough. So what you need just a web interface to define it, or I don't know, these mappings. And also, if you look at the step functions in AWS, you have a connection between API gateways and step functions, which is completely, which is with no code, just integration. So you can make really complicated stuff with no code. It doesn't really matter if it's Java or something else, because there is no code. So yeah,
that's mind-blowing that you can actually do that these days without writing code. And I remember years ago, so much effort was involved in making these things work and optimizing them.
Yeah. But also there is a strong community of Java developers who still tend to build things like websites and stuff that don't really need all these capabilities, you know. So you have to ask yourself a question: do you need like 200 milliseconds cold start, or you are fine with 2 seconds of cold start for a website that you're making? If you have a low traffic, and why would you invest so much in some things, you know? So many people don't really have that kind of a need. So it's a big question. Do we as developers pursue this technical excellence, no matter if we do some simple websites? So it's on us, you know. Sometimes I would go for these super optimized things, even if we just build small websites. You know. But the big community is not really big part of the community is not changing their habits. They're still using Spring Boot, which is I don't know. I don't like it.
So I'm going to jump in and do the raffle, and people can ask more questions afterwards if they like. So we have kind of an unusual raffle situation in that at the last meeting we raffled off what I thought was a pretty cool prize, and the person who won it never contacted me to claim it. And it's a prize that's going to go away if we don't use it. So I'm going to raffle it off again. And I'm sorry for the person who didn't reach out last time, but it's been 2 weeks. So the prize is a 1-year membership in A Cloud Guru, which is a pretty wonderful training platform. So I'd say only try to answer this question if you really want it. And if you do win, just send an email to me, briantarbox@gmail.com. And the way we do this is we're going to ask the question and type the answer in chat, and the first winner wins. And this one, Ken, I'll let you do it.
Oh, okay. So since we're talking about Java today, I thought we'd go back to historical Java. So what was Java called before it was called Java? What was its original name of Java? First person to type into the chat will win.
Wow, that was quick.
Oh, there you go.
All right. So Anton, do you really want this? And you know, because I really want to give this away.
Well, I do have corporate subscription, but I do know a couple of folks who would really use it personally. But if that's against the rules, just do another quiz and I'll stay away from it.
What do you think, Ken?
I think it's fair if he can pass it along.
Okay.
I think that's, yeah.
Okay. All right. Cool. All right. Anton, send me an email, briantarbox, all one word, @gmail, and I will forward your email to our contact at A Cloud Guru. Excellent.
Well,
Okay.
congratulations.
Thanks.
It's fun to win, even if you're not going to use it directly. But now you can be Santa Claus and give it to someone else.
Right. So I want to. We may have more questions, but I want to really thank Goran for this really amazing presentation. And Goran, what time is it right now for you locally?
I don't know. It's 1:18.
1:18 a.m.
A.m. Yeah.
A.m. So this was an amazing giveaway. So thank you very, very much.
It's called Developer Standard Time.
Yeah, yeah.
Yep.
So I'd say why don't we let him go to bed?
Okay. Thanks, guys. I mean, I really enjoyed. Whenever you have any questions, just push it on Twitter or wherever you like. Okay.
Yeah, fantastic. This is
excellent.
This is a great talk.
High density.
Thank you very much.
Yeah, yeah.
Yeah, I'm just using in production, so it's easy, you know. So I don't really have to prepare too much, you know, for these things. So try these things, and you will see how these things are great, even greater than you saw it now. Thank you, guys.
All right. Thank you so much. And thanks, everyone. And we'll let you know what we're doing in December. But everyone, stay safe and stay healthy.
Yeah, thanks, everyone, for joining. And join us on Slack if you want to be part of the conversation about what we might do in December. We can continue the discussion there. All right. Thanks. Take care, everyone.
Bye-bye.
Bye-bye.
Good evening.